Maybe for a brief introduction about Lillian. She's a dedicated data scientist with a wealth of experience in the world of banking and financial institutions. Lillian holds a Bachelor of Science degree in computer science from Strathmore University, and also a master's degree in analytics from the prestigious Georgia Institute of Technology in the US. And she brings a unique blend of expertise to the table. Her passion is empowering organizations to unlock the full potential of their data. She is a true advocate for steering organizations towards data-driven approach, which she does with finesse and a lot of passion. So last session we had was on data preprocessing, as I've said, and EDA, and she took us through a very interesting journey. And today now culminates the journey on data preprocessing and EDA with now a practical real life data science use case. And Lillian, you may have the floor. I'm sure the session is being recorded. Thank you and welcome everyone.
Thank you so much, Kigo, for that introduction. Yeah, so my name is Lillian, and as Kigo has given you my bio, that's who I am. I have worked mostly in the banking sector, in the financial sector, for the 7 years that I've been working. And I'm really happy to be here, and I'm honored to have a second session here to just take you through what we had discussed in the first session. So I think we can begin. So the session today is practicals on data cleaning and preparation, and also just how to do EDA. So the way I'm going to take this, or rather the approach that I'm going to take, is this, to take you through a data set and sort of walk you through the different steps that you would follow to try and gain insights from a data set. We don't have a data science task or a machine learning task, but we are just going to do the cleaning and also the EDA. But I hope that the way I'll take you through it will give you sort of an idea of what steps to follow when you're given a data set and you're asked to come up with insights or try and prepare a presentation or a dashboard for stakeholders in your organization. So I think we can start. I will be sharing my screen. Okay, just a minute. I don't know if you guys can see my screen.
Yes.
Okay. So the data set that we are working on today is the billionaires data set. So every year Forbes releases a list of the top billionaires in the whole world. So in 2023, they released that list in April, and that's the data set that we are going to work on. So we'll take on a journey to try and understand these billionaires. What are their ages? What industries have they made their money in? Who's the youngest? Who's the oldest? Do we need to clean the data, or is it ready and clean enough for us to just work on it on the get-go? So that's the journey that we are going to take on. So as I've said, we are going to look at the billionaires data set, and the data set has several variables, and some of the variables that are probably important for us are the rank, and this is just the ranking of the billionaire. So I think it goes from rank 1 to around 2,600 and something. Then there's the final worth, and this is the amount of money that billionaire is worth, and it's in billions. Then we have the category, and this is the industry that that billionaire business operates in, or the industry that they made their money in. Then we also have the name of the billionaire, the age, the country they're from, the city in which the billionaire resides in. And maybe I can just repeat for country. The country is where they reside. So it might not necessarily mean...
Excuse me, Lillian?
Yes?
We are able to see your screen. I think you're sharing the wrong window.
Oh, sorry, just a minute. Mm. I believe you guys are seeing now the correct screen.
Yes, we are now on the notebook.
Okay. I'm so sorry about that. Thank you for pointing it out. Yeah, so as I was saying, for country, it's a country that the billionaire resides in, and it might not necessarily mean the country of their citizenship, because I might be living in Kenya, but my citizenship is not Kenyan. Then we also have the city where the billionaire resides in. Then the source of wealth. This ideally is the company or the business that that person made their money in. So like, let's say for Elon Musk, it would be Tesla. That's the source. Then for industries, it's the industries it's associated, the industry associated with a billionaire's business. Then we have now country of citizenship. So country of citizenship is where you are a citizen of. You might not be living in that country, or you might be living in that country. Then there's the organization, the name of the organization or company associated with a billionaire. Self-made, so this is a Boolean, which indicates whether the billionaire is self-made or they inherited their wealth. Then we have this status, and this ideally means self-made billionaires, it's D, where it's the founder or the entrepreneur, and U, where the wealth is unearned. But this particular column, as we are going to continue seeing, is not very well populated, but maybe I'm getting into it. So then we move on to gender, and this is just the gender of the billionaire. Then we have details about their birth. So their birth date, you have their name, first name, last name, the title. Then the date, this is the date of the data collection. Then we have state, but this one is for the United States. So the state where the billionaire resides in, the resident state region, the birth month, birthday. Then we have now details of the country that they reside in. So we have the consumer price index of the country, the change in the consumer price index of that country, the GDP of the country, the gross tertiary education enrollment. And tertiary education, I believe, is just after primary school. So have you gotten any more education after primary school? Then we have gross primary education, we have the life expectancy in that particular country, the tax revenue in that particular country, the total tax rate for that country, the population of the country, the latitude, and the longitude. So this is the data that we are working on. So we will now move on into the work that we have done for this particular data set. So we'll start first with importing libraries. And initially, you'll probably have an idea of the libraries you'd want to use. And I think the most common ones is the Pandas, NumPy, Matplot, so for visualizing, Seaborn as well for visualizing. And then these two here, so we have Folium and we have GeoPy. These ones are going to help us with plotting. So Folium is a library for Python for plotting maps. So if you want to see a visualization of like the whole world and you want to pinpoint different aspects of different countries, then you can use Folium because it's very intuitive and it provides you with very nice maps to use. Then we have
Excuse me,
GeoPy
Lilian.
and yes.
Is it possible to increase the font size of your notebook for legibility?
Okay. I
And
don't know where I don't know where I can do that. I don't know if anyone knows.
Is it under view or something up there where you have view?
Oh, okay. Just a minute.
Appearance, yes, I think it's somewhere there.
Okay.
And then
zoom out. Is it zoom out or zoom in? Yeah.
yes.
So Is it better or do I increase it a bit more?
Brian,
Increase it a bit more. Yeah, that's better. That's better. Perfect.
This is better, yeah? Okay, awesome. Thank you. So I was talking about the libraries. So most times you'll probably know some of the common libraries you'll use, but some of them you wouldn't know. And as you just go along with your data analysis, what you'll do is if you need a new library, you'll just come and put it here under importing libraries so that your notebook is a bit clean. So that's the first thing we did. Then now we move on into, so I'll just be running the notebooks as we move on. Then we move on now to just reading our data set. So we'll use pandas to read the data set, and it's a CSV file, and we are going to use read_CSV from pandas. So we just read the data set, and we have it now in our notebook. Then we take a peek of the first few rows of our data set so that we just see what we are working with. And we can see here the different columns that I had initially discussed. So it will not show you everything because you can see here there are some columns that have not been displayed. And we'll have to, if you want to see all the columns, you'll probably have to like use a different function to check all the columns. And I think even just at looking, when you look at this data set, even just from the first look, you'll see that here GDP_country, we have it in object. It's not a float. And ideally GDP of a country is supposed to be a number. So we'll need to clean this up. And it's something that we have already noted just by looking at our data set. So we have a look at the data set like that. And then now we also move on to looking at how many rows are we working with. So ideally we have here 2,640 rows and we have 35 columns that we are working with. Then we have some important methods that we can use to get a better understanding of our data set. And we have already used the head. So this one just prints the first few rows of your data set, or you can also use tail, which gives you the last few rows of your data set. Then there's the D types, which gives you the data types of the columns that we are working on. Then we have info, and it just gives you a bird's eye view of the column data types and the number of missing values in the data frame for each column. Then we have describe, and this one returns a distribution of the numeric columns in your data frame. So it's smart enough to know that this one is numeric, therefore we need to give the distribution, and this one is not, so we just exclude it. Then we have is NA, and you can pipe it with .sum so that you understand how many missing values do we have for each particular column. Then we have .is unique, and this one gives us the number of unique values in our data frame. So in the data frame column that we are interested in, and you will see us using this. Then we have the displot, which plots the distribution of one column in your data frame. And you'll see us using these different functions as we move along. So now we move and look at the data types. So we look at the data types here and we can see that, So we can see here that rank is an integer, final worth is an integer, category is a string, the person name is a string, age is a float, and the one that I think we were interested in was the GDP of the country. I don't know if it's here. So maybe you can just look at it. And we can see that the data type for GDP country is actually a string, because when you see this one, it just means object. It's a string, but we need to change it back into a float so that we can work with it in a way that makes sense. So that is something that we've noted, and we will work on it as we clean our data. Then we move on to checking the number of missing values. So here you can either use is null or is any, as I have discussed earlier. So this just gives you a breakdown of each column and the number of missing values for each particular column here. And we can see that some of the columns have a lot of missing values. So if you look at the organization has 2,000 of filling in the missing values, and if the missing values are too many, it's too important for our analysis and we need to keep it. And if we are keeping it, how are we going to impute the missing values such that the see that the ones that have a lot of missing values is title, the state, the resident state region, sorry, the organization. So those ones we've just taken a note of by just doing analysis on our data sets. And then we also have this here. It just gives you a distribution of the numerical columns in your data set. And here we see that for rank, we have 640 of them. So there are 2,640 of them. Standard deviation, the minimum, of course, is 1, and then the maximum is 2540. And you might ask yourself, why is the maximum 20? You have 2640. And this is because that there are some ranks that were tied. So like, let's say billionaire number 5 has a net worth of 118 billion. And then the person who follows him also has a net worth of 118 billion. Both of them need to be rank 5. But now you will miss rank 6. You will not have 5, 5, and then 6. You will have 5, 5, and then now you have to move to 7. That's why you can see it looking like that. Then there's the final worth, and this is just how much each billionaire is worth, and you can get a breakdown, and you see that the richest person is actually worth, I think, 211B, and the one who's on the billionaires list and is worth the least is 1B. Then we look at the age and we see that the maximum or the oldest person is actually 101 years old. The mean is 65.14. And then we also see that the minimum is 18. So there's someone who's actually a billionaire and they're 18 years old. Then we move on to the birth year, and the birth year, of course, will be related to the age. And yes, it will be related to the age because you calculate, of course, your age by subtracting the year that you're in minus the year that you're born. And we see that the maximum, this actually does not look right. And I did not clean it up. Oh, sorry, yes, the maximum, this one looks right. So the maximum is 2004, and this one will translate to the person who's 18 years old. And then the minimum here is going to be 1921, and it will translate to the person who's 101 years old. Then we have the birth month, the birthday. Then now we have the details of the countries. So we'll have, of course, the CPI for country, and we see that the country that has the highest CPI is 288. And the one with the least CPI is 99. And the mean CPI, or the average CPI for all the countries represented in the list, is 127. And the same goes on for each other numerical variable. So I believe this is a very good function to just look at because it gives you an understanding of your data set better even before you start your proper analysis. Then we move on now to the, I hope I ran this. We move on to the info, and the info just gives you like a peek of what your column represents. So it tells you the data type and whether it's a not null, or rather it gives you the count of non-null values in that column. So we see for rank, there's no null value. Then for final worth, no null value. Person name, no null value. Then age, there are some null values because we see that we have 2575 and yet we are meant to have 2640. So there are some null values in age. Same for country and city and so on and so forth. So that's just how you get a feel of your data set before you can even now do a deep dive into the analysis that you need to do. So from all that analysis, we see that there are several problems. So problem one is that the GDP country column is a string with a dollar attached to each price point. We need to convert that to a float if we want a good understanding of the data set. And then we also need to make sure that the date columns are date time. Because I think if you look at some of these dates, like birth date, I don't know if it's here. So you see it's a string, but we need it to be a datetime object if we are going to use it anywhere. We are not sure we are going to use it, but it's just best practice to change all the dates to actually date and not to have them as strings. And then we have missing data problems, and we can see that there are missing data in some
excuse me.
Yes?
There's some hand up from Samuel Kigo.
Okay. Sorry, Kigo. Please
Yes.
go on.
So up there, where we have the info, just the previous chunk. Yes. Down here on data types, on the results of that chunk, on the data types, we have a Boolean, we have float, and we have int. So what is the difference between float and int? Because we have float 64 and int 64.
Okay, that's a very good question. So float is any value that has decimal points. And then int, it's just an integer. So if we are saying that you're rank 1, it's not 1.0, it's just 1. But if the data comes in as 1.0 as rank, then that one is going to be put as float. So I think for easier understanding and easier differentiation, you just need to remember that int is just a number without any decimal points, and float is a number with decimal points. Even if it's 0.0, it will still be considered as a decimal point. I don't know if that's clear.
Yes, thank you very much.
Okay, and if you have any question, please feel free to just unmute and let me know, because I can't see the hand up when I'm sharing my screen. So please feel free to just stop me. So we'll move on, and we see that we have missing data, and that's something that we need to tackle. So number one, we'll first fix the GDP by the GDP column. So we need to first remove the dollar sign, then we need to remove the commas, and then we need to convert it into a float. And the thing that I did here is I used a function. So I just created a function called GDP to float, and this function can be reused because most times when you get a data set maybe that has price, you'll find that it's a price that has a dollar sign and has some commas and some decimal points. So it will be considered a string and not a float. So this function can be reused here. So the first thing you just do is the function takes in a data frame, which is the DF, and it takes in a column. So this is the column that you want to convert. Then we come here and we replace the dollar sign with a blank. Then we replace the blanks inside. Maybe I can just go back to it, sorry. So you see there are blanks. There are some spaces in between. So what you'll do, you'll need to remove those spaces. Like when you remove, I think you first remove the dollar sign, then you will remain with this part. If there are any spaces, that's what we are trying to treat by removing the space. Here, so we remove the space, then now we remove the comma that we have, and we replace it with nothing, and then now we eventually convert it into a float. And then we return our data frame with a treated column. That's the first thing. Then we move on to converting any string that is meant to be a date into a datetime object. And this one is a very simple function. So it takes in, again, the data frame and the column that we want to convert into a datetime. Then we come back here and we use the toDateTime function, yes, toDateTime function in pandas to convert that column into a to-date time data type as compared to being a string. Then we return our treated data frame. Then now we move on to problem 3, which is missing values. And this one is going to take a lot of the work that we are going to do, trying to replace the missing values. So the first thing I did, I wanted to see the ratio of missing values for each column. So how many rows do we need to have? Ideally, we need to have 2640. How many missing values does each column have? We say maybe 2000. What's the ratio? Is it greater than 70%? So 70% is just an arbitrary number that I picked. It doesn't have to be 70%. It depends with your problem and what you're trying to resolve. So if it's greater than 70%, in this case, we'll just say, you know what, it has too many missing values, let's drop it. So that's what this function does. So the first thing we're doing here is we're calculating the percentage of missing values, and we're just taking the number of nulls each column has divided by the length of our data frame, which is going to be 2640. Then we get the missing ratios. So once we get the missing ratios, I created here 2 dictionaries. So we have high ratio dictionary and we have low ratio dictionary. And this dictionary takes key value pairs, and the key is going to be the name of the column that has missing values, and then the value is going to be the percentage of missing values for that particular column. I don't know if I am clear. So we have divided it into high ratio and low ratio. And high ratio is the ones which are above 70%, or 70% of their values are missing. So those ones are going to be in this particular dictionary. And this is the condition that makes sure that it's only the ones which have missing values above 70 or equals to 70 that are put in this dictionary. Then the low ratio are the ones whose missing values are either below 70. So because here we've already taken care of 70. And we return 2 dictionaries. So we have high ratio and low ratio. Maybe I need to be running this once. And maybe we can just sorry. I don't know if you guys would want to see the high ratio and low ratio because I did not display them, or we can just move on. Then for the high ratios, I decided that we are going to drop them, because if 70% of the columns are missing, what we might impute, but we might impute with the wrong things. So it's better to drop them. At the end of the day, we had 35 columns. And if we have 3 that have a lot of missing values and we drop them, then ideally we might not be losing a lot of information. But I think this one will just depend on your problem, and you need to really analyze, are the columns that I'm dropping really important for the analysis? And if they are, maybe you can try and find another way of treating it. You can go back and collect your data, or you can ask the business. It really depends. But in this case, we are going to drop them. And this is what we are doing here. So we are coming here and feeding our data frame. So the data frame that has all the missing values, and then we get this particular dictionary that we created at the top here, and we feed it into this function. And what we are going to do is, if the name of a column in our data frame matches the key in the high ratio dictionary, then we are going to drop it. And that's what this piece of code does here. Then we return our data frame after dropping the columns that have high ratio of missing values. This one is a function that runs all the, are they 3 or 4 functions that I've just described here? And what it does is that it just takes in, it takes in a data frame. So a data frame that is not yet treated completely. And we first get a data frame out of converting the GDP to float. then we convert the birth date into a date, then we convert date into a date. Then here we we calculate the missing values, we calculate the ratios of the missing values, and we assign it to either a high or a low dictionary, depending on how many missing values are there. Then eventually here we come and drop the columns with the high ratio of missing values, and we return a data frame that we can now use to continue with our analysis. So I shall just run that, and now we can get a data frame that will now continue using. So this is the data frame, the billionaires data frame. And maybe we can just get a peek of how many missing values we have now. So we can just do is now. And you can see now we don't have those very high values because we've dropped them. The ones that were like 26 something, those ones we've dropped them, and that's why we can see, maybe you can just see here. So you can see here we just have the columns that did not have a lot of missing values, and we have dropped, I believe, 4 columns because we started with 35 and now we are remaining with 31 columns. I don't know if anyone has a question until that point. If not, I think we can move on. So in as much as we have dropped some of the columns that had a lot of missing values, when you look at our data set, there are still some columns that have missing values, like these ones and these ones at the bottom here. So we need to replace these missing values. And you need to take different approaches to replace missing values, because the way I'm going to replace missing values on age is not going to be the same as how I'm going to replace the missing values in country. So it's really dependent on the column, the knowledge that you have of your data set, and also the people that you're working with. They'll be able to help you and tell you, maybe for this particular column, most of the people who don't provide their details, they are in this category. So it really depends, and you need to have that knowledge before you even embark on filling in missing values. So we'll take different approaches, and maybe I will just skip this. Then we now go to age. So for age, how are we going to replace the missing values? And I've described here how we are going to do. So the first thing we're going to do is we will calculate the age by subtracting the birth date of the billionaire from the date the data was collected. So you might find that we are missing some age values, but yet we have the birth date. So that's the first best way of replacing age, because you know that you will actually have an accurate age of the billionaire. But this will not guarantee us that we'll fill in all the missing values we have under age. So what do we do if we haven't replaced some of the missing values? We decided here that we are going to use the median. And we decided to use the median because median is not sensitive to outliers. So it will not be pulled to one side because they are outliers. But in our data set, after looking at it, it's almost normally distributed. So even a mean could still work. But we used the median. So the first thing here is we identified the missing values in age, and then we came here and replaced those missing values by subtracting the date from the birth date of the millionaire, and then we filled in those missing values. Then for the ones that I think the next thing I did here was actually to impute the birth date. So I did not continue first with the age. So I imputed the birth date, because you'll find that there are some birth dates which are missing, but yet we have the age. So what do? You just subtract the birth date from the date. so that you understand when was this person born. So that's what this code does over here, so that we impute the birth date. Then the birth year, birth month, birthday, what we did is, for this birth date that we have collected here, there are some values that will be missing for the birth year, birth month, and birthday. So what do? We just extracted the birth year, the month, and the day from the birth date. That's what we did. That's what we are doing here. Then for anything else that has remained, whatever that has not been filled in using those previous methods, then we used the median. So we calculated the median of age, and anything that had not been filled in, we fill it with the median. Then same for the birth year, we just calculated the median of the birth year, and we imputed it, same as the month and the birthday. For the birth date, this particular one here, we did not calculate the median because you also need consistency. So you cannot calculate the median here because I don't think it will guarantee you that now the birth year, birth month, and birthday will match this birth date. And ideally, they should match because you want consistency. So for this particular one, we did not calculate the median. What we did is, from the median that we've gotten from birth year, birth month, and birthday, we now brought them together, or we combined them to create the birth date. And that's how we replaced the missing values for these particular variables. Then now we move on to the country, imputing country, because we have some missing values in country. So you can see here, we have 38 missing values in country. So what we decided to do is, for country of citizenship, we don't have any missing values. And I thought, ideally, for most of the billionaires, you'd find that they've made their money in their country of citizenship. So even if we make a mistake, it's not going to be a very huge deviation from the truth. So we just imputed the countries that were missing with the country of citizenship. And that's how we replaced missing values in country. Then now we moved on to the city and first name. This one I decided to fill in with unknown, because in as much as we can guess the country using country of citizenship, we might not necessarily be able to guess the city. It might be a good assumption to say that you probably live in the capital city, but that's not true for a lot of people. You might have made your money in a different city as compared from the capital city, especially in some of these developed nations. You find that the capital city is just as big as any other city in that country. So that's why we decided to fill it with unknown. First name as well, we just filled it with unknown because we cannot start guessing the first name of a person. Then for the rest of the variables, which are ideally the CPI, the CPI change. So these are the numerical variables that represent a country. These ones, we just decided to use the median to fill in the missing values. You can look at it in a different way. So what you can do is, you might decide to cluster countries using the CPI, the GDP, and you're able to know, like let's say for Kenya, if we don't have CPI for Kenya, but we know Kenya is very similar to Tanzania, and we have data for Tanzania, the best thing that we can do here is to replace the CPI of Kenya with Tanzania's CPI as compared to using the median. That's not what we did here, but I'm just giving you guys ideas of how you can impute, and that you're not limited to just using mean, median, or mode. You can think outside the box and say, let me cluster, and for whatever country, if you belong in a certain cluster, then I'm going to either use the median for that cluster, or I look for a country that is very similar to your country, and that's what I'm going to impute. But in our case, we used median. Then we move on to the longitude and latitude. So we have the longitude and latitude for the countries, right? And for longitude and latitude, I don't think it would be right, or it's not right to replace it with, say, median, because longitude and latitude pinpoints a place. So what do you do? So the first thing I did here is, there are some countries you remember that we had replaced using the country of citizenship. And probably that country of citizenship, we already have its longitude and latitude based on the people who already had that country as their country, and the longitude and latitude had already been filled in. So we just picked the longitude and latitude for any country that was already existing, and we don't have the longitude and latitude. So that's the first thing we did. And that filled in a bit of the missing values for longitude and latitude. I don't think I've been running this. Let me just run them. So that one filled in our values for longitude and latitude, but we still had some countries which did not have longitude and latitude. This is now where we use the GeoPy library that we had imported earlier on. It has, is it actually GeoPy library? No, it's Nominatim library, and the GeoPy is, it's like a function within Neonatim library. And what it does is that you can give it the name of a country, and then it returns, no, you can give it the longitude and latitude, and then it can return to you the name of the country. And this one is built on, I don't know if you guys are familiar with, I think it's called Maps.me or something. So it's a maps that this library has been built on. And this is the one now we used for any country that we do not have the longitude and latitude. We would feed the longitude and latitude into the library, and then it would give us the name of the country. And the way we did this was
yes,
the first thing
just
is,
a minute on the same. Sorry for interjecting.
No,
On
it's fine.
nominative. So
Uh-huh.
you've said that if you give it latitude and longitude, you get the name.
Uh-huh.
Does the same
Yes.
work when you give it the country name? Could it populate the longitude and latitude for you?
I haven't checked that, but I believe it's possible, because there's a way that you can reverse the, you've asked if you give it the name of the country, whether it can give you the longitude and latitude.
Yes.
Yeah, I believe it is possible, but I might have to confirm that. The only thing I've seen that is possible is that it can also give you the name of the continent, but I haven't implemented it. I'm not sure if it can reverse the country into longitude and latitude.
All right. So when you give it what do you do for you to get the name of a continent? Is it that you give the dimensions?
No, it's the same
The
thing.
latitude?
So what you,
okay.
Yes, so you give it the latitude and longitude, and then it will give you the name of the continent.
All right. Thank you.
Yes, yes. But it's a very interesting library. So the way that I did it is I got all the countries which the is it the longitude and latitude of all the countries that we did not have. So get me the, I don't know if I have missed any. Oh yes, so here, this is the code here. So I am creating a list with all the names of the countries where the latitude is missing. And it puts it into a list. And I can just run that. We can see these are the countries that don't have the longitude and latitude. And we used here unique, because if you don't use unique, it's just going to repeat itself. But we just wanted the countries that don't have longitude and latitude. We don't care how many times it appeared. So these are the ones which we are interested in. Then we come here and we create a dictionary. And this dictionary is going to have the key as the country name, and then the value is going to be the pair of the longitude, latitude. And I can just show you guys that it takes a bit of time, especially now, even like with the continent one. It was taking a bit of time, so I didn't even implement it. So you can see this, it looks. So you see now, this, by just using this part actually is the one that gives us that. So you see that we have now the longitude and latitude of Hong Kong, for Taiwan, for Eswatini, for Bahamas, and so on and so on. Then now we come here, and for any of these countries here, we know that they don't have their longitude and latitude. We go back into our data frame and we replace them using now the correct longitude and latitude. So this is what this code does here. And this is just for the country items using median. And now we have here our final data frame. And now let's check whether there are any missing values. And we see that we have actually treated all the missing values in our data set using those steps that we followed. Ideally, the steps might be different depending on the case that you're working on and the different aspects of your data set, the different aspects of the business. It will be different, but this one is just to illustrate the different ways you can do it. Now let's move on to the exploratory data analysis. And this was the interesting part, because now we are trying to understand our data in depth. And I went, the approach I took is I took different columns and just tried understanding those different columns by themselves. So we start with age. So let's check the distribution of wealth by age. And I was using Plotly Express to do the visualizations. And I like Plotly Express because it allows you to almost interact with your visualization. So you see, like here, when you hover, it tells you the median is 65, the quartile 1 is 56, quartile 3 74. Even when you come here, it tells you the age is 65, the count of people between ages 65 to 69 is 415. So this is the age distribution for all billionaires. So we have not broken it down into either female or male. And we see that it's almost a normal distribution. It almost follows a normal distribution. And then we see that a lot of the people are between ages, is it 45, 49 to around age 84. So most people fall in between that age group. Then we also see that we have some outliers. And these are the people who are below the lower fence. And the lower fence is 29. So ideally, if you're a billionaire and your age is below 29, you're an outlier. So this means that it's very rare to see a person who's young and they are billionaires. So that's something that we'll also look at again. So based on just looking at it and saying that it looks like most of the billionaires fall in between ages 50 and 84. What now I went to do is I calculated the probability distribution of the ages.
Sorry, excuse me.
Yes, please.
Yes, I think I may have missed the part on plotting the histogram and superimposing the box plot. I would like to know how you've done that. You have the histogram and a box plot on the same frame.
Okay, so this is the code that does it. And it's actually, I think, a functionality of Plotly Express. And the one that superimposes the box plot at the top of the histogram is this particular one over here. And you can even change it to say a violin plot, like let's say that. You see it changes. So it just gives you, I feel like you get more with just one piece of code, because this would have mean we prepare a histogram and then we also create a box plot or a violin plot. and there's another one called a rag plot. So yeah, it now sort of gives you like count or something. But I found like the box plot was the one that gave more information. I don't know if that answers your question.
Yes, and I find it really interesting.
Yes, I also really liked it when I discovered it because it just made my work easier. Yeah, so we move on to the probability distribution of the ages, because now we have just looked at it and we have thought, you know what, most of the billionaires look like their ages is between 50 and 84. What's the probability that someone is between the ages of 50 and 84? Yes, what's the probability? Sorry. And we see that the probability is actually 80.12. So we are probably right. Most of the billionaires are between that age. Then now we look at the outliers, because we've seen here that the lower fence is 29. So anyone who's below the age of 29 is an outlier. And we see how many do we have here. And we see that we have 10 of them. And there are how many males? 6 males and 4 females. Three of them are from Italy, South Korea, Norway, China, United States. So yeah, so it just gives you an idea of what we are working on. And this guy here is the youngest at 18 years old. He's in fashion and retail, and he's from Italy. But also looking at these names, they all look the same. So I don't know if they're brothers. They probably are brothers. I did not look at that. So those are our outliers. Then we come here and look at who's the youngest billionaire. And we see that the youngest billionaire is Clement de Vecchio. He's in fashion and retail. He's 18 years old. He's from Italy. He's not self-made. So it means that his health is inherited. Then, of course, he is a male, as we've seen here, and the source of his wealth is actually from selling eyeglasses, which is interesting if you think about it. Then we move on to the oldest billionaire. And the oldest billionaire is George Joseph. He's in finance and investments. He's 101 years old. He's from the United States. This guy is self-made and he is male, of course. And the source of his wealth is insurance. So this one, we have understood the distribution of wealth using age. That's what we were just looking at here. Then we move on now to looking at the distribution of wealth between genders. And so I just made some notes. You find here that the distribution of wealth between male versus female billionaires is actually huge. So the male billionaires make up 87.2% of all the billionaires in the world, which is huge. And then the females make up only 12.8%, which is a very small percentage if you think about it. Then now we come and look at the age distribution for the male billionaires. Does it follow the distribution for the entire data set, or is it different? And we see that it follows ideally the same distribution, and most of them are between the ages of 49 to around 84. So ideally it's still the same. The median is 65. And then here the lower fence now for the male billionaires is actually 28 years old. So if you're below 28, then you're an outlier. Then we look at the age distribution for the females, and we see that the median is still the same, which is 65. Then the lower fence for the females is 35. So this is actually interesting. So for females, if you're below 35, then you're an outlier. Even if you're 33, you're still an outlier. So a lot of females don't make, they do not become millionaires from this data set. I'm not saying that that's the truth, but from this data set, most female billionaires don't become billionaires until maybe like they're over 35. That's what the data is telling us here. And we see that the distribution is still the same. So 49 to around 79. So you see that for this one, it's a bit different. For the males, it was up to 84. For the females, it's up to 79. Then here we want to see.
Sorry, just to take you back. This is a light one.
Yes, please.
What informed your choice of color between male and female? Is it informed by something?
Yeah, because okay, I like pink, and I thought the females I'd represent them as pink, and then for the males I'll represent them as blue.
Yeah. Okay. Just to understand, because I think is part of sharing the data that will drive some sense in it, which is very interesting.
Exactly.
Yeah.
Yeah, and also most times when you look at the color representations for females and males, I know there's a lot going on in the world right now, and you're told not to box people. But most times in history, you'll find that a lot of people would represent males as blues, even for babies. When you're doing like baby shower parties, you'll find that for a boy, it's going to be blue. For a girl, it's going to be pink. If it's gender neutral, you'll find that you're either using grays, greens, yellows. But in this case, I chose to use blue and pink.
Yeah. Okay. Amazing.
Yeah. Then here, I don't know what I was trying to do here. Yes, I think I was looking at the richest female. Who's the richest woman? Yes. So who is the richest female? And we see that it's this lady together with her family, and she's actually, I believe, the owner or the founder of L'Oreal. So L'Oreal is a huge fashion and retail company from France, I believe, and they actually are in Kenya as well, and they bought the company for Nice and Lovely. So that's just on a lighter note. That's the richest woman. Then here we look at the top 5 richest women, and we see here an interesting thing. You'll see that this one is Miriam Adelson with family, Julia and family, so and so and family. And this ideally means that it's like a family-owned business. And when you look at whether they're self-made, none of them is actually self-made. Not that it's a bad thing. It's just an interesting thing to note. And most of them are from the United States. Only the first lady is from France. The rest are from the United States. Now let's move on to the richest man. And we see the richest man is Bernard Arnault and family. So this guy is also, it's like a family-owned business. And this is the guy who actually owns, or I think is the founder of Louis Vuitton, Moet, and Hennessy from France.
Sorry for
again.
interjecting again. Sorry, I'm sorry for interjecting.
No,
where
it's
we
okay.
have the source,
Uh-huh.
does it point us to the owner of the business, or maybe have some significant investment in the business? For example, the L'Oreal.
Uh-huh.
Could it mean that this Francois lady,
Uh-huh.
is she the owner, or she has a significant investment in it, or do you have maybe some more info on the source?
So it might not necessarily mean that they are the owners, but you'll find that most times they're the founders or co-founders. So ideally, I think the best way to put it is that they have a significant investment into the company, and you'll probably find that they're the ones who started the company. That's how I saw it, because I was actually just going back and trying to research on who is so and so, what did they do, how did they make their money. And like for this guy, Bernard, he is actually the founder of Louis Vuitton, Moet, and Hennessy. So he's the founder. You'll find that, of course, now they probably have investments from other people, but he is the biggest shareholder, he's the founder. So for the most part, he's almost like the owner of the business, but not in the sense that the entire business belongs to him. they might have other people who've invested into the business. So yeah, and then we move on now to the richest men. And what is interesting here is that as compared to the females where everyone was not so self-made, here only Bernard is self-made. Sorry, he's not self-made. The rest are self-made. And I believe most people know these guys. So of course you have Elon Musk, Tesla, then you have Jeff Bezos, Amazon, Larry Ellison, Oracle, and Warren Buffett. Those are the guys who are the top richest men. The four of them are self-made and they're from the United States. Then we look at the countries with the most female billionaires, and the United States is number one with 99 of them. China following with 54. Then we have Germany, Italy, and India. Then we go to the males, and we see that for the male billionaires, it's actually the same. You have United States, then you have China, then India moves up. India now is number 3. Then we have Germany, and instead of Italy, we have Russia. So those are the countries with the most male millionaires. Then we also look at the categories. So what are the categories that most female millionaires have made their money? And we see that food and beverage, together with manufacturing, take the number 1 spot, with 45 billionaires being in those industries. Then we have fashion and retail, technology, and finance and investments. When you look at the male billionaires, you find that there's a difference. So finance and investments is the first one. Then we have technology, and manufacturing now is the one that comes number 3 as compared to here where it was number 1. Then also healthcare is there, and fashion and retail appears in both. So that's the insights that we get when we look at the gender, the wealth distribution between the different genders. So we move on to looking at the industries now. So when we look at the industries, how many industries are represented in this data? And this is where we use the .unique function, and we see that we have 18 different industries that have been represented in the data set that we are working on. Then let's look at the top industries, the top industries that have the most billionaires. And we see that finance and investments is the one that has the most billionaires, because there are 372 billionaires in finance and investment. Then manufacturing comes in very close, then technology, fashion and retail, and the last one here is media and entertainment. Then we look at the bottom categories, and it's interesting to see here that the list is actually gambling and casinos. You would think that probably gambling will give someone a lot of money because the house always wins, but it looks like if you even do another kind of business, you can still be a billionaire. I found that interesting. So these are the bottom 10 industries with the most billionaires. Then now let's look at the wealth distribution by country. So how many countries are represented in our data set? We see that there are 79 different countries that these billionaires reside in. So we look at the top countries with the most billionaires, and we see that the United States has the most billionaires, with 755 of them living there. Then China comes in not very close at 523. Then we have India, Germany, United Kingdom, and Taiwan, which is a very small country actually, has 46 billionaires, and Hong Kong as well. So it's interesting when you look at it like that. The bottom countries, this one, I did not even plot it because most of them are just one. So you find like there's only one billionaire in that country. And so there's like Oman, and I think this one has been ranked alphabetically. So there are probably even more countries which have just 1 billionaire. But even before we move on, you'll see that United States together with China, they almost make up 50% of all the billionaires in the world. I think they make up around, yes, they make up 48.4% of all the billionaires in the world. And maybe it's because the countries have very high GDPs and high populations, but it's something interesting to state. So we decided to look deeper into the billionaires in China and the United States, and we wanted to see what industries do these people work in. And we saw that it's actually different from the data on the top industries, because here we see that technology for China and the United States, technology is the #1 industry that has made these people billionaires. Then finance and investments come second. Then we have manufacturing, and until we have sports. And these are people who play sports. So you'll find a lot of basketballers. I don't know if footballers would be there as well. So yes. Then I thought it would be interesting to see, is there any billionaire who has more money than their country's GDP? And I thought this was not going to be possible. Ideally, you shouldn't be richer than your country. But it was interesting to find that there are actually some billionaires who are worth more than their country's GDP. And all of them were from a tiny country called Monaco. So they live in Monaco, but we see that, like for this guy, Eyal, who has a lot of money, he is worth 18.9 B, and his country's GDP is 7 where is it now? Yes, so the GDP of his country is 7.18, and he's worth 18.9. This guy is Israeli, so the country of citizenship is Israel, but he now lives in Monaco. Then we also have this guy from Belgium, but he now lives in Monaco. So these guys are actually worth more than their GDP when this data was collected, because I checked the GDP of Monaco. By the end of 2023, it should be around 9 point something. So ideally, using this data, only this guy is the one who would be worth more than his country's GDP. I found that very interesting. Then another thing I decided to look at, is there anyone, or rather how many people have made their money at home or have made their money abroad? And at home here will mean that the country I reside in is where I have made my money and I am a citizen of that country. If I have made my money abroad, it means that my citizenship is different from the country I reside in. So that's one thing I decided to do. And here I created a new feature. And this is what we would call probably feature engineering, where you use the data that you use the columns that you already have to create new columns. And so I created it, and we wanted to see how many, just a minute, the distribution between home billionaires versus abroad billionaires. And as you would expect, the people who've made their money at home are more than the people who've made their money abroad. So the home billionaires are at 89.5, and abroad we have 10.5. Then we went a step further and looked at, for the people who've made their money away from home, like if you've made your money abroad, which country is this that has gotten a lot of non-citizen billionaires? So that's what this code does over here. And we see that the country with the most non-citizen billionaires is actually the United Kingdom, followed closely by the United States. And then we have Switzerland. And I believe most of us know that Swiss it doesn't have a lot of restrictions. So a lot of people also prefer investing there. So we went a step further and checked for these UK foreign billionaires, these people who have come to invest in UK and they've become billionaires, which country are they from? And we saw that 7 of them are from Sweden, 5 from the United States, Canada, 3 France, 3 Russia, 3. So these are just the top 5. Then for the people who've made their money abroad, there's another question I asked myself is, if I have gone to make my money abroad, which country has the most people leaving their country to go and become billionaires in another country? And I decided to look at that as well. And when we looked at it, Russia was the one which had the highest at 25, then Canada, then United States, and so on and so forth. And so for the Russians, I wanted to understand, for these Russians, which country is this that has given them such a good environment to invest until they have become billionaires? And we see that Switzerland is actually the one that has the highest number of Russians who are not Swiss, but they have become billionaires at 7. Then Israel, Cyprus, United Kingdom, and Australia. So Switzerland, as you know, doesn't have a lot of restrictions, and maybe that's why people prefer to go there and invest, and they've become billionaires. Then finally, this is the folium that I was talking about. It's just like a library that helps you plot your data and allows you to see like your data better if you have like maps data. And I think, as I had told you, I was not able to do like a continent, to create a continent column, but I was also interested in seeing how many billionaires have made into this list who are from the African continent. And you see from this map, it's very easy to do. So if we click on the location, it tells you what country that is and the number of billionaires in that country. So we see Morocco has 2 billionaires, Algeria has 1 billionaire, Egypt has 4, then we have Nigeria has 3, and our neighbor Tanzania here has 1 person. Then a very tiny country called Eswatini has 1, and South Africa has 5. So those are the billionaires in Africa. Then of course you can just keep looking and checking. Like this is the British Virgin Islands 1, Cacoyes Islands 1. So I found this a good way of just visualizing your data set and trying to understand how many billionaires are there, where are they, how does the map look like? Is it that there's a huge cluster somewhere? Like if you look here, you can almost see clusters, and this is Europe. So probably there are a lot of billionaires in Europe. Then this is North America, this area over here. Then you have South America on this side down here. So that's it for the wealth distribution by country. We now move on to the self-made billionaires versus the billionaires who've inherited their wealth. And not to say that it's not very interesting to look at the guys who have inherited their wealth, but I was very intrigued by the people who are self-made, and that's the one that I really focused on here. So we will look at the number, and we see that 68% are actually self-made. So most of the billionaires are actually self-made, and then 31% are non-self-made billionaires. So these are the people who've inherited their wealth. So now let's look at the top richest people who are self-made billionaires. And we see that here, all of them are males. All of them are males, and 8 of them are from the United States, and then 2 are from, like one is from Mexico, and then another one from Spain. But it looks like United States is somewhere that a lot of people are able to invest and they make money. Then also like tech, because tech has 5, which is 50% of the top 10. Are the guys who are the top self-made billionaires. And of course, here you're seeing companies that we know of: Google, Microsoft, Amazon, Oracle, Tesla. We see Bloomberg, Yeah, there's Warren Buffett and Zara. So Zara is like a clothing brand that is all over the world. So those are the top self-made billionaires. We don't even need now to look at the top self-made billionaires males, because all of them are here. Then now we look at the non-self-made billionaires and the top non-self-made billionaires, and we see that most of them are actually just families, because you can see these ones are families, and at least here we have some females. So we have this person here, L'Oreal, of course, and then Walmart. So there are some females appearing here. 5 of them are from the United States, and then we have other countries appearing. Then now let's look at the women self-made billionaires. And we see here that it's a mixture. So you have United States appearing 3 times, then you have China appearing 3 times, you have Russia, you have United Kingdom, and Rafaela is the richest self-made billionaire lady, and she's made her money in shipping and logistics. I don't know what company she founded. I didn't read on that. Then we want to see the youngest self-made billionaire who's also male. Here we have Ryan Breslow. So he's from the United States. He's 28 years old, and he's in e-commerce software. So this is actually the co-founder of Bolt, the same Bolt that we have here in Kenya. This is the guy who was a co-founder to it, and he's the youngest self-made billionaire. And of course, also he doubles up as the youngest self-made male billionaire. Then we now look at the youngest self-made female billionaire, and we see that here it's actually a tie between Melanie Perkins and Rihanna. I believe we all know Rihanna, the musician. So she's actually from Barbados. Her country of citizenship is Barbados, but she made her money in the United States. So ideally, she is also among the people who we say she made her money abroad. Melanie Perkins is from Australia, and if you know Canva, so it's a software that helps create cards. It can even create CVs for you. She's the founder, she's the co-founder and the current CEO of Canva from Australia, Sydney. And she's among the very few women who founded tech firms, and she's the CEO of that tech firm. Then we look at the countries with the most self-made billionaires, and we see here again the same trend. We have United States, and then we have China, then now we have Russia, India, and so on and so forth. Lastly, now we'll just look at the correlation analysis. And here we are trying to see, is there really correlation between different variables and someone becoming a billionaire? And I think the one that I was interested in is seeing, does the GDP of a country affect whether I'll become a billionaire or not, or the CPI of a country, or the tertiary education enrollment. So if the tertiary education enrollment in my country is quite high, is there a higher chance of becoming a billionaire? That's what we are trying to look at here. So the first one is a relationship between the GDP of a country and the number of billionaires. And I don't think there's really a relationship here. I don't think there's a linear relationship such that if the GDP of your country is very high, then the number of billionaires is going to be very high. It looks like there is a bit of a relationship, but I'm not very convinced. Then we also look at the CPI, and it's the same thing. There isn't a very clear relationship that you can see. Then we also look at the tertiary education enrollment of a country, and it's the same thing here. And I think we can just conclude that in as much as we have a lot of data and we are trying to get correlation analysis, then we might have to collect more data and try and see what factors influence someone becoming a billionaire. And I just wrote something here. This just means that we probably need to evaluate the other variables, because here I have just looked at 3. So GDP, CPI, and tertiary education enrollment. And we might also need a bit more data to see whether there are any factors that influence how many billionaires are in a country. It can be infrastructure, it can be anything really. And it doesn't necessarily mean that because there are many billionaires in a certain country, there are certain factors that have directly affected the number of billionaires that are in a country. And lastly, here I just plotted like a correlation matrix for all the numerical columns. And I just thought that it's interesting. And for this one, it did not really give us like a snippet into the number of billionaires as compared to the other numerical columns, but it was showing us other relationships. Because if you look at like the life expectancy of a country, it's highly negatively correlated with the CPI of a country. Then if you also look at the tax revenue of a country, it's negatively correlated also again with the GDP of a country. So these are other things that you can just look at, and it can allow you to even move on now forward into more data analysis. And that is the end of my presentation. Thank you.
That's really amazing. And for me, I've learned so much. I think that's why even if we have taken more time, for me, I was concentrating. I've learned so much, and I believe for every data scientist, present here, be it your beginning or you're somewhere, this is one of the platforms that you learn so much. Even getting to hear from Lillian, who is a BC senior data